Assalamualaikum and hello everyone. We are third year student in Manufacturing Engineering at University Technical Malaysia Melaka. We would like to design our product for integrated design project that we call Foot Door Opener. We prepared this video for our panel and our supervisor. My name is Nurfarhah Binti Adenan. I will start with background of study. The problem scenario for this study are there will always have many risks that will be considered when handling the doorknob during this pandemic because the viruses may spread through touching the surface of the doorknob. The spike of cases in Malaysia has been daunting since the viruses cannot be seen by naked eyes and it only can be prevented by social distancing, wearing a mask, reduce physical contact and sanitize regularly. COVID-19 is a virus that can cause death. Besides that, people tend to bring a lot of stuff in one time in order to save their time and energy. It will be difficult for them to open the door if there is no one to help them. Moreover, as we can see, some of disabled people facing trouble to open the door, especially people that using wheelchair, people that did not have hands, and people that using walking stick. In order to solve this issue, we design and develop a product that can reduce physical contact and help people to open the door easily. The objective of this project are: first, to design and develop a device mechanism that are able to open the door without using hand. Second, to analyze the effectiveness of the device in terms of usability. Third, to validate the developed prototype using simulation software and using functionality tests. There are a few limitations for this foot door opener. First, the device can only attach at normal wooden type of door and doorknob. Second, it only can be attached at 1 meter from the bottom of the door to the doorknob.
Thank you, my fellow comrade, and greeting to our respected panel. Assalamualaikum. My name is Muhammad Aufa bin Saufe. For this presentation, I will be present about the 3D model of the product and product description. This is our foot door opener 3D model. As you can see, it is a two-part device to open the door. The idea and design of this product is to avoid hand contact on the doorknob during pandemic era. This product can help people with hands full of lifting objects and also for disabled people. This product is very user-friendly and easy to install that later I will show you in the simulation. First, I will talk about the top part of the product, which is the doorknob adapter. This is the assembled dimension and the exploded view for the doorknob part. The doorknob adapter have a two item, which is the main and the half. The main of the doorknob one has an extra dimension with hole in the end for the cable to go through it, and the other half is to cover the other side of the doorknob. The material of this main and half of the doorknob adapter is the 3D printed ABS plastic material. Then we have nut and bolt, which is stainless steel. This is the assembly simulation for the doorknob. The main and the half we attach to the doorknob and then we lock it using bolt and nut. This is the bottom part, which is the pedal part of the product. We can see here the assembled division and the exploded view. There are three items, which is a cover pad made of rubber, a machine process of pedal and bracket, which is made of stainless steel. And next is the assembly simulation for the pedal. The cover pad will be inserted to the pedal. Next, we will mount the bracket on the door using screw. Make sure it's aligned with the center with the doorknob adapter, and then insert to the bracket. For extra part, we have a cable and a clip. Both are made of stainless steel. Since the length of the door is various, we cannot expect the exact value for in the drawing. We just assume it 80 cm long from the bottom of the door to the doorknob. Since the both parts are separated, we using stainless steel cable and attach it to the both hole of the pedal and the main doorknob adapter, and then using a stainless steel clip and to clip the cable. This is our solution. When the pedal is under force to the pedal, the door will be rotated downward. Thus, it will unlock the door as the cable in the middle will act as pulley system when we attach for both parts. This is the function of our product, which is to prevent using hand contact on the doorknob as to reduce germ and virus spread. The product is very easy to install and assembly. It does also help the user to open the door while hands are full or when lifting object and even for disabilities people. Okay, next I will show you the finite element analysis result for bottom part, which is the pedal part. For first principal stress, the indicator show the color blue is the minimum stress and the red is the maximum stress. The force we're using to push the pedal is 100 Newton. We can see that the maximum value is 34.61 megapascal occurred in the inner corner of the pedal. As for displacement, with force of 100 Newton, pushing the pedal, we can see that the pedal is sliding downward along the bracket for 80 mm. For the safety factor, the value of the pedal is minimum of 11.07 and the maximum value is 15. As for the top part, which is the doorknob adapter for stress analysis, the force we're using to pull the doorknob adapter is 100 Newton. We can see that the maximum stress value is 2586 megapascal occur at between the main adapter and the half adapter. As for displacement, the max value is 4.141 mm downward. What I can analyze is when the force is applied downward, it will deform both adapter by rotation on the doorknob, thus it will show a grip to the doorknob. So the safety factor for doorknob adapter is minimum value of 0.1 and maximum value of 15. It shows it can break or fracture as more force applied to it. So the optimized result should be more than 1. As my final slide in my part of presentation is the needs of every part of the product. The pedal part mostly is made of stainless steel because of high corrosion resistance. As for the cover pad, is made of rubber, is for safety of the sharp edges and dampening the force when stepping on it. The doorknob adapter is made of ABS plastic, is very light and strong when having a pulling downward force. For bolt and nut, it will be act as a locking system and also to grip the doorknob adapter. And lastly is the cable and clip. Will act as the medium for doorknob adapter and the pedal part, and also to be a pulley system mechanism. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fathullah bin Harani. I would like to present about the process involved in producing the food door opener. There are basically 5 processes involved in this production. Moving on to the first process is laser cutting. It is mainly a thermal process in which a focused laser beam is used to melt material in a localized area. It offers many advantages in producing our product, which is high accuracy and precision cuts can handle jobs for almost complexity, higher metal sheet utilization with less waste and low power consumption. The parts that involve laser cutting process are foot pedal and the bracket. Next is bending process. It is a method in which metal is deformed by applying force to the subject, causing it to bend at an angle from the desired shape, which is V or U shape. Bending may be used to impart strength and stiffness to the sheet metal and improve the moment of inertia of the component and enhance aesthetic appearance. It removes the sharp edges. This process is involved in producing the bracket. Next is drilling process. It is a process of cutting holes in metals by using a drilling machine. These are tools to remove the unwanted material in a rotational motion through the material. The process is done by feeding the workpiece into the rotating drill. This process is applied to the doorknob adapter and foot pedal. Welding process is a material joining process. Two parts are connected together at their contacting surface by suitable heat and pressure. MIG welding process has been chosen to fabricate our project and it using the heat of an electric arc. The parts that involve welding process is bracket part and foot pedal. 3D printing is the object created by laying down successive layers of material until the object is created. Each of these layers can be seen as a thinly sliced cross-section of the object. 3D printing enables to produce complex shape using less material than traditional manufacturing methods. The parts that needed 3D printing is doorknob adapter parts. The product will be divided into 3 parts. For the first part is foot pedal, will involve laser cutting, welding and drilling as the manufacturing process, while for the bracket part it involves tap welding, bending, drilling and laser cutting, and for the last part, which is doorknob adapter, we decided to use 3D printing due to its complexity of the shape. That's all from me, and I will pass this present to the next presenter, Nurfarhah. Thank you.
Thank you Fathullah for the process explanation. Assalamualaikum and good day. My name is Nurfarhah Binti Mohamad Khairi. Now, I will present and show you the estimated cost in order to produce the foot door opener. First of all, as shown on the screen right now is the bill of material, which is a source of information that lists all parts and raw materials needed to produce 1 unit of a finished product. Therefore, the total for all of the materials listed are RM8.44. Next is the variable cost, which is an expense that can change in proportion to production output or sales. Element of cost included in this variable cost are material costs, labor costs, and other expenses such as electricity, utility, hand tools, and cutting equipment. Hence, the total for variable cost is RM19,843. Move on to the fixed costs. Fixed costs can be a contributor to better economies of scale because fixed costs can decrease per unit when larger quantities are produced. Hence, the total of fixed costs to produce the food door opener is RM10,245. Now, we move on to the prototype and manufacturing cost per units. We measured the prototypes and manufacturing cost per unit by adding the total variable cost and total fixed cost divided by assume that 500 products can be produced in a month. And we get a value of RM60.18. On top of that, taking into the account of margin percentage of 50%, the profit margin we will get is RM9.03. And finally, the selling price per unit for this food door opener is RM69.20. That's all for the estimated cost for food door opener. But what about the sustainability of this product? I will pass it to the next presenter to discuss about it. Thank you.
Assalamualaikum, I am Abang Mohamad and I will explain about the sustainability. First of all, in selecting the best material for our product, we use the material selection method that you see as EduPack software to filter out the best material. By using the following constraint, we pick 5 most suitable material to continue with the scoring method. As a result, stainless steel has been chosen as the best material to fulfill the design requirement for the product. Life cycle assessment is a holistic approach used for a product impact assessment. There are 4 major components to the food door opener, which are doorknob adapter, foot pedal, cable, and mounting parts. The material used in the parts consists of ABS plastic that is a lightweight material while maintaining the structure integrity. On the other hand, stainless steel parts are made to be high tensile strength and resistant against corrosion, which are great in handling force that has been applied to the foot pedal. All the material that has been used in developing this product are recyclable and reused by reprocessing the material into raw material. By end of the life cycle, foot pedal, doorknob adapter, stainless steel cable, and the mounting part can be recycled, and this will help in keeping the environment safe from waste and pollution. Next is Eco Design Web. Eco Design Web is performed to analyze an existing product or design. It accesses different environmental areas, which are the material selection, material usage, the distribution, lifetime, and the end of life of a product. The purpose of this activity is to analyze the environmental performance of our product. As you can see, the end of life and optimal life of the product is in a great position as the product is made from stainless steel, which are a good corrosion resistant and can be used in a long term. The product also has a good distribution score as our product only weigh 0.932 kilos and come in small size, which is easier to be packaged and transport. Then, eco indicators are used. Eco indicators are numbers that are assigned to show how much each part of the product affects the environment. In this project, eco indicator 99 is used and the results are shown as follows. The value for eco indicator for production phase is 765.82, while the use phase it indicates the value of 411.45. And for the disposal phase, the value is negative 57.487. To sum up the total value, we have obtained a total number of eco value of 1119.8784. As conclusion, we can conclude that all the following objective has been achieved. Perhaps the device looks simple, but it surely will give a big impact to the community in preventing a spread of germ through direct contact. The cost of the product is only RM69.20, which are quite affordable. Not only that, this device will give a big hand to disabled user and helping a person with both hands occupied that has problem with opening the door by hand. Thank you. That's all from us.